making, right? Said in our program, sometimes we need, most of the time we need to capture, make some decisions. Just a minute. We need to make some decisions, and those decisions will be based on the inputs to the program or whatever you computed. Okay, so just like this, if I have a score and I ask the user to input his or her score, then I used this scanf function, which allows me to be able to key in or input the value from my keyboard, right? So you need to specify where you want to save whatever you type and which is the address of score. Okay, so the syntax is you have a comma specifier followed by address of the variable you want to store your data, right? So it means with this line 9, you have a value being saved in score. So score has a value. Then we want to make a decision if this condition is true. I want you to print you got A. So if score is greater or equal to 70, and score is less or equal to 100. So you can see this logical operators. Okay, so this relation must be true, and this must be true before you can have an output. Okay, so the statement must be true, everything here must be true, and for it to be true, both of these conditions must be true and these must be true. So in an AND state and logical operation, the two conditions must be true before you have an output. So otherwise, so if you have several conditions you want to check, you can then use else if statement, then you continue to check while the last is an else statement. Okay, and when you're through, you can exit. All right, so that's the decision um which you can use an if statement. You could also use a while statement. You can also um, use a while and do while statements also, okay, to check. So we'll move to what we call iteration. Iteration is when you want to execute a statement a number of times. Iteration, okay? You want to execute, more like you want to do a loop. You have a statement you want to continue to execute, then you would use an iteration. Okay, so the keyword you will use, one of the keywords you will use is a for loop, the for command. Okay, now you use for loop when you know the number of times you want that statement to be executed. All right, so it has its own syntax. One thing about programming also is when you start coding, you need to follow the syntax or more like the rules of the game. Okay, so let's imagine you have n, which tells you the number of times you want something to be executed. All right, so I have a for statement, okay, and with the for statement, you can say the condition will be in the bracket. You have what we call the starting criterion, the stopping criterion, and the incremental. Where do you want to start from? Okay, so I can also create a variable. Let's say I equals int I. You can say I want to start when I is equals 0. Okay, maybe I want to print I. Okay, I want to print I. So I starts from 0. When do you want to stop? I will stop when it's less and equal to 100. So it means I want to print from 0 to 100. Then how do you want to increment? To increment, it means the number of steps you take. So you increment by 1. So if you want to increment by 1, you type plus plus I or I plus plus. So those two are not the same. Okay. So before that, let me quickly tell you about this operator plus plus I and I plus plus. It's an incremental operator. Okay. So let me quickly show you. So if you have I, let's say I equals 1 now, I've already declared I. Okay. And if I want to increase I by 1, I will just say I equals I plus 1. Okay. I've incremented I. So, so with this, I've incremented I. I is 1. And I said, oh, I plus 1 should now be the new I. So it's just like wherever you see I, that's 1. 1 plus 1, which is 2, is now be written back to I. So I becomes um 2. Okay, so you can run it, see what you have. Okay, so the value of I is 2. Oh, sorry, the value of I is 2. Yes, the value of I is 2. Okay, so this is another way you will write it is by saying I plus equals, so it means increment by 1. So, okay, you can see I incremented it by 1. That's 3. All right. So that is just a short way of writing it. If you want to divide by a number, that same I, let's say I want to divide I by 2 or 3. So you can say I, and I want to update it because I divided by 3. Okay. So I currently is 3. 3 divided by 3 should now be saved in I. So I should be 1. Okay. I is 1. So like I showed you the other time, another a short way of doing that is to just say I divided by equals to 3. And that will still give you 1. Okay. That will still give you, right. So that's how to increment. You can also increment by a certain number. Let's say I equals I plus 2 or plus 5. So it means the former I, which is 1, plus 5, which is 6, should now be saved in the current I, right? So you can do that. All right, so you have that. So now let me talk about the incremental. You could do this plus plus I. This is a unary incremental. Plus plus I means increment I by 1. Okay. So if you do that, let's say I is 1 plus I would now give you 2. Okay, I will become 2. All right, it's still the same as if you say I plus plus. So yeah, I is 1. Now I becomes 2. Now I becomes 3. So okay. So remember, plus is a binary operator. Plus is a binary operator. That is to say, it takes two variables, A and B. It takes two variables, add them together, then it can now put it in another variable. But at least for any given time, plus is a binary operator. For plus plus is a unary operator. Unary means depends on just one variable. Okay, so that is that. So I've been able to now the same way applies to if you say if I increase by 1, I can also decrease by 1. So I can say minus minus I. Minus minus I. Here I is 1. This line 9 I is 2. Line 10 I is 3. By line 11 I becomes what? I becomes, so the final result should be 2. Okay, so that is that. But there's still difference between this and this. Okay, there's still a subtle difference between the two. Now, this you will see this unary symbol plus symbol is before this variable I, and this unary symbol is after the variable I. Here we call it prefix, prefix. Okay, operation, and here we call it post, post. Okay, postfix operation. If we are using this unary operator on just a variable, you will not see the difference because you are just incrementing the variable. You won't see the difference. However, you will see the difference if you are casting it to another variable. So let's say n equals this, and let's say n equals this. So let's do this. Let's do this. Okay, that's the value of n, and let's press n. Let's see what happens. Okay. So before I explain, the unary operation is this. Let me just give you more like a gimmick, which I always tell my students. You will see before, remember that when you have an assignment operator, it means whatever is on the right hand side, the operation that is carried on the right hand side is now placed in your variable on the left hand side. So if you say n equals a plus b, it means compute, first of all, do the addition of a plus b, then whatever result you have, place it in n. Okay, so um, so that's that. All right, that's that. So where am I going? So if you look at this, you will see it first of all tells you increment I. The first thing you see is increment I. So I was 1. First of all, increment I, then I becomes 2, then 2 is placed in n. So here n is 2. N is 2. But when you do a postfix operation like this, post, it means post means more like do it later. right? The first thing it does is it places I into n. So I is 2, okay? If you look at this from here, n is 2, I is also 2. I is also 2, okay? But if you come here, it first of all insert the value of I into n. So n will be 2 before it carries out the incremental. Then I becomes 3. Okay, so for the prefix incremental, it first of all increments before it assigns. But in postfix, it assigns first before it increments. So with this, we'll see n equals to, I can also modify my code. Let me modify my code. The value of n is this, okay, um, is this, and I is, okay, let me just come to a new line, and I is, I want to clear my screen, clear. So the value of n is this, it places the value here, come to a new line, and I is, let me just do this, give it a tab, and place the value there, right? So then I copy it, paste it here. Let's see so that we see it very well. So let's increment and see what we have. Oh, okay. You can see the value of n is, let me just see. N is this and I is this. So you can see n is 2 and here n is I is 2. For here, n is 2 and I is 3. You can see. So sorry. Okay. So that's just it. That's it. So n is 2, I is 2, n is 2, I is 3. Why? Because at this level, it first of all assign the value before it does the incremental. Okay, so I hope that is clear. Is that clear?
Yes, sir.
Okay. So let's go back to our for loop. A for loop is used to be able to execute a statement a number of times. So let's imagine I want to print out a value I from 0 to 100. Okay, so with the for loop, I have what we call a starting criterion. Where do I want to start? I want to start when I is equals to 0. I want to stop when I is less or equals to 100. And I want to increment by step. Then, so then, what do I want to execute? What statement do I want to execute? Are we on the same page? What statement do I want to execute? Remember, it is the statement that is in this curly brace that will be executed a number of times. Okay, that's the statement you want to execute a number of times. So I can just print it out, print I out, I is I just give it a start spacing and print out the value, the format specifier. Okay, I is, then I put I there. Okay, so I is this. This statement will be executed 101 times. Okay, or I can start from 1. I want I to start from 1. Okay, so I is this. I'm coming. Sorry, I is 1. Okay, sorry, I is 1. Then come to a new line. Sorry. So you can see I is this. I started from 1, 2, 3, 4, 5, 6, 7. You know, up to where does it stop? According to my code, I said it should stop at when it's less or equal to 100. It means when it's 100. Okay, so you can see um, the number of times you want something to be executed. You can just say, "Oh, I love the program. I love C program." Maybe that's what you want to do 100 times. I love C programming. Maybe that's what you want. That's 100 times. You want to keep executing. Okay, you're done. Remember, you have a starting criterion, semicolon, stopping criterion, okay, and incremental. Now, if I want to increment by 2, what do I do? I want to increment by 2. Remember, at this incremental, I, I wrote plus plus I. What if I want to increment by 2 or by 5? It means the number of steps I will be jumping will be maybe 5 steps, 2 steps. So what do you do? What do you think I would do? Let me print I. Um, I equals. What do you think I would do? So class, what do you think I would do? I want to be jumping, let's say by 2. I can't hear you. Where you are is noisy. Write it in the chat box. Okay, write it in the chat box. Let me see. Instead of I plus plus, we use I plus 2. Good. Okay. So it says I plus 2. Oh, sorry. I plus 2. Let's see if that is true. I plus 2. Let's see.
It was meant to be I plus.
You can see it's we are having an error. Okay. Let me show you. What you would do is
I,
you would
I,
just say I equals I plus 2. Or you can do this I plus equals. Okay. So but I understand where you're coming from. It means you're incrementing I by 2. You can see I started from 1, jumped to 3, to 5, 7, 9, 11, and all that. Okay, so you can see the steps is being jumped by 2, right? So that's that. So a for loop you can use it to execute a statement a number of times. Now you can have a for loop within a for loop and within a for loop. Okay, so so you can have a nested for loop statement. We call it nested for loop statement. Okay, so let's see. Now, if you have a nested for loop statement, how do you go about it? Apologies, the network I was using Adeniyi timed out the table. All right. All right. So, as I was saying, if you have, let's say, a, a 2D dimension where you want to access rows, you have rows, also you have rows. Then, if you have to access individual blocks, you have a for loop that will help you traverse the rows. Okay, let's say X. So X will be changing from here to here, okay, down here, right? Then you have another for loop. So you'll be using two for loop, another for loop to help you traverse what? Your column. All right. So what you do is while you are still on row, the first row, the step inner for loop will help you traverse all the columns until you get to the last column. Then this outer for loop then move to the next row. Again, the inner for loop will traverse. So while the outer for loop, execute once, the inner for loop will execute certain number of times. All right. So let's see how this work. Let's see how this works. Let's say I want to implement a times table. Remember when you're still much young, or even up to now, your notebook, at the back of your notebook, you always have times table, right? True of course. So you have your times table. So now let's say you want 12 times table, 12 times. Okay. So 12 times, you have one time, let's say one times, two, two times, three times. So you always have a column for 4 times, okay, 5 times. So you have a row, you now have a row to say, okay, 1 to 12. So 1 times 1, you see 1, 1 times 2, 2. So you multiply the rows with a column. So here, 1 times 2, you have 2. 1 times 3, you have 3. 4 times 1, keep adding this. Then 2 times 2, you have 4. 3 times 2, sorry. 3 times 2, you have 6. 4 times 2, you have 8. 5 times 2, you have 10. Okay, so let's implement this. Let's implement this using for loop. So you first of all have a for loop, the outer for loop help you traverse the number of rows. So we'll be having 12. So let's just say 12. Hmm, let's just say, and you increment by 1. Okay, that's 4. Then you have your inner for loop. Then you have a counter to help you count, the column. So J equals, let's say 1. So that J that equals 12. Okay, J plus plus. So what happens? What happens in the times table? What happens in the times table is you multiply and you print it out. You multiply um, the I and the J. So print F, um, what do you print? J. Okay, so I times J. So I, when I times J, do this. Okay, so that's what it does. Okay, so if you run it, let's see how it goes. You will see it does not fit to our table. Okay, let's, let's see. Sorry, I wonder what I've written. I was okay. Step through. Okay, I start from 1. I less equals 12. I plus plus. Okay. In the loop, you have this print. Okay, the main plane. In workspace. Also this. Now, this is not what I signed up for. Now, it's somewhere. right? So I think that I should be J. No. Oh, sorry. I've seen it. Yeah. Thank you. Yeah. Thank you. November. So, so you can see now, you can see, um, but it's not properly formatted. So what's the issue? Okay. We will see by the time it got to 12, it continues. All right. So it should be when it gets to 12, it should come to a new line and print. So let's see. So after you're done with the row, a row comes to a new line. So let's see. F. So after a row comes to a new line. Let's see. You can see now it's properly formatted. Thank you. With that, Toluwani, thank you so much. I wasn't looking right. So you can see this column is 1 times, so it's 2 times, 2 times 2, 4, 6, 8, 3 times, 3, 6, 4 times, 5 times, up to 12 times. Okay, so that's how you can use your um loop iteration. Okay, how you can use iteration to be able to do all this. All right, is this clear enough, class? If it's clear, you can comment in the chat box. I need several comments so that I know we're on. Okay, so you can see that for dimensions, or you want to traverse, we'll get to a concept called array. When you want to traverse your array, you will use a for loop. For loop will help you traverse. Okay, you can move or execute a statement in a number of times. All right, so there's also what we call a while loop. A while loop, just like for loop. For loop is used when you know the number of times a statement will execute. While a while loop would is used when the number of times you want to execute is not known. So while more like as long, okay? So the statement will be in quotes, then you put whatever you want to do in your while loop. Now, in while loop, you always have, you initialize your count. So let's say let's just say I equals 10. Okay. I can say while I is greater than 0. I want to start from 10. Okay. I want to start from 10 and I should decrement to um I should decrement to 0. So while I is um greater or equals to 0, okay, print what's up? Print um I just want to print I. Okay. Remember, for any loop, for any iteration, it's always good for you to have a starting criterion. Okay. I starts from 10. Okay, a stopping criterion. This I will stop when it is greater or equals to 0. That is to say, when it equals to 0. Okay. Starting, where is it starting from? I is starting from 10. Increment, stopping, and can have your incremental. I minus minus I. It means I'm decreasing I. So when I starts from 10, is 10 greater or equals to 0? Well, 10 is greater, okay, than 0. So it executes this statement. It prints I. Okay, let me just say print I, and let's say come to a new line. It prints I and come to a new line. Then it decrements I. I now becomes 9. Is 9 greater than or equals to 0? Yeah, it's greater. So it continues, right? It continues till when it's now 1. 1 is 1 greater or equals to 0 is greater. It prints 1. Is 0 greater than 0? No, but is it equals to 0? Yeah, it's equals to 0 prints. Okay, so it stops. Oh, sorry, my return statement. Okay, so return. Yeah, so you can see 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so it stops. Okay, so first your condition is checked. Check before the statement is executed. Hmm? It's checked before it's executed. You cannot, it will not run until this is true. Okay, until this is true. So you can while true. Sorry, I don't want to use while while true while true. Print this. So if I want to print to infinity, I just continue to print. Okay. So these will just keep printing the same statement. Oh, with that. So this will keep printing to infinity. Okay, you can see it's printing 10 to infinity. So let me stop it. Okay, so why this is true, you can see 1 is true. Anything inside the parentheses must be equal to 1. Okay, must be true. So true, this is true. So you just keep printing. Okay, so while statement would always will always execute Okay, as long as the condition here is satisfied. Let me give you an instance of using the while loop. Another instance. So let's say you have a character choice, and I say choice, and my choice initially is yes. Okay, yes. Then I can come here and say while choice, as long as choice is equal to yes, as long as choice is equals to yes, print um print I love you. Print I love you. As long as okay, so you can see I have my starting criterion, I have my stopping criterion. I will stop as long as when my choice is not equals to yes. Why? Okay. Then ask myself, I can say um, print F. I can ask you, do you want to print again? Do you want to print again? Let's just say Y for yes and others, other key, other for no. You understand? Do you want to print? So come to a new line. Y for yes. So then eh, the um the um the sorry. So so with this, as long as this choice, whatever you print, well, choice is initially yes. As long as choice is equals to yes, print I love you, then this come to a new line. Do you want to print again? Whether you want to print I love you again. Okay. So if you type yes, this keyboard, this waiting for input, yes, it comes again. Is it yes? Is this the person press yes? If it is yes, as in why, it will print I love you again. It asks you. So it will keep printing till you press any other key. It does not stop. There's no limit. Like for loop where you have to specify, oh, for starting, stopping, okay, where you want to stop. But for a while, it keeps, you know, iterating until a condition is met. So let's see. Okay, I love you. Do you want to print again? Why? Enter. Oh, I love you. Do you want to print again? Let's see. Why does it stop? Let me see. Um, I think because there's an enter key. Okay. Okay, let me see. These are issues with C where you have to flush. You have to flush. You can see. So, but you need to understand how it works. Because of the enter key, let me see. Uh, let's see. Uh, um, see if I can just use a wait. I love you. Now, input. Okay. Yes. Yes. Good. Do you want to? Yes. Good. Do you want to? Yes. 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 You understand? Now, the issue I was having the other time was uh with scanf. Whenever you type your option like yes and you press your enter, enter is also a character. There's something we call string. Okay. So if I press let's say yes, my enter key is in the string, input string, more like input queue. Imagine you have a stream or a pipe flowing from your keyboard to your processor. Okay, from your keyboard to your processor. So whatever you type will be saved. So you press Y for yes and your enter key. It accepts this, it goes to your choice. Okay, it goes to your choice. It's saved in this variable. Okay, so the next time you type, oh, do you want to continue, and you want to type yes, what comes again, what's in still in your queue, your input stream is this enter key. So it will not allow you to even press put in your choice. This just goes. Okay, so that's the issue I had earlier on. So what I just did is every time I press my option, I key in my option, I use this to accept whatever is left in the queue. Okay, I just use this to hold it temporarily. I'm not using it just to hold it. So the next time I type Y and I press enter, the enter is received into this flush variable. Okay, that is why I was able to overcome that. Sometimes you just have to be smart about all this. Okay, so do you want to continue? Yes. See, keeps repeating itself until I press any other key, it stops. Okay, so that's a while loop. So there's also another one called do while loop. Do while loop. So the difference is you have you have do here. Do means execute this, perform this iteration while this condition is what? This condition is true. Okay, so do execute this statement or body of statement while this condition is satisfied. Now, one beautiful thing about do is it would allow you to execute a statement at least once before you check for your condition. It allows you to execute a statement at least, at least. Okay, so that's that. So let's see. Let's see. I think it's so. Do you want to continue? Yes. Yes. So any other key? So that's do while loop. After setting the loop, can I make an exemption which is Adeniyi? What do you mean? Adeniyi. Hello. So that is do while loop. Okay. So another thing we will can learn today is what we call the switch statement. You can also learn the switch statement. The switch statement allows you to um, jump to a certain part of a code and execute what is there. Okay, it's just like this. Um, at home, we always have what we call a switch. I want to ask you, what switch, how many switch or how many switches do you know or do you use at home? Or have you heard of anyone? I hope you are still with me. Switch statement. Are you still with me? Can you hear me?
Yes, sir.
We can hear
Okay.
you,
How
sir.
many
But,
how many switch have you heard? There is one switch you use at home, especially um if you have different sources of power. You have generator, you have your, let's say you have an inverter or a solar system, um and you have the electric supplier, let's say power holding. We see have power holding, PSN, let's just say PSN. Okay, so you have your switch. So if you want to on your generator, okay, and you are on power holding, you have to take your switch and switch it. Okay, your switch will help you to, you know, move to any of these supply. Okay. Also, yeah, when you use the switch statement, let me show you. Let's say I have in choice, and my choice is one. Okay, my choice one. You can use the switch statement, this choice, and in your switch statement, you build a case. You build a case and say, oh, if the choice is one, what should happen? If my choice is one, what should happen? I should just say, let's say print F, you selected one. Let's say this is what I want. So when you build your case, you have to break it. Okay, so you can also come to case two, case person press two, and let me just okay. So if it is one, if my choice is one, it will test my choice and say, oh, this is one. It takes you to the appropriate case and execute what is in it. So you select one. If it is two, it jumps here. Select. Let's see. You can see it, you selected one. If this is two, it looks for a case that matches it. Okay. Say, okay. Two. Oh, sorry. That's it. Oh, you selected two. Selected. Okay. Something like this. Imagine you visited the ATM machine and it tells you select the transaction you want to perform. So let's say it tells you one is to deposit. So let's say one is to deposit, two is to transfer, three is three is to top up. Top up, get something like this. There's also a in your case, there's something we call default, where you whatever option you selected in the switch statement, it does not match it. So let me just default the invalid option. Invalid option. Okay, so if I select any number, it will take me to the appropriate case, execute it, and stop. Okay, so case one, if I choose two means transfer. So two means transfer. If I select three means it will execute the statement. The statement I have here is top up. Okay, so you can see top up airtime. Right. Now, I want you to know that after every statement, you have to include your break statement. The instance is to tell it when you are done executing the statement, I want you to stop. This is the boundary for case one. If you choose or you forgot to include the break statement, it performs the statement and jump to the next case. Okay, so let me choose my option as one, and you will see it display deposit and transfer. You don't want to execute the two statements. Okay, so it's important that you break. Now, if any choice you selected is not in this case, what you selected is not in this case, it will execute what the statement under the default option. So 10, it will say invalid option. You can see it's invalid. Okay, so we did this if our option is an integer. What if it is um, a character char? So let's say my choice is A. My choice is A. So when you're building your case, you have to say it's A, is B, is B. Okay, so let's run. B. A means deposit. B means transfer. And let's say I just space bar, space nothing. The default option will be selected. Okay, so that's it about using the switch statement. Remember what the option, what you want to switch or what you want to test, you place it within switch. Okay, and you build appropriate case. And always remember for every statement under each case, you have to include a break. It is only the default you don't need a break. Okay. So now break statement is used to stop. stop a sequence of activity. Okay, so I can let me show you how to also use the break statement. So let's imagine I'm doing a for loop. I have a for loop, and I say, let's say int I equals 3. Start from 3, stop at in 14. Let me print 8. And let's say let me say I want to print uh, I log C, right? Now I can come here and say if I is equal to 10, if I is equals to 10, break, stop. If I is equal to 10, when it increments and it gets to 10, it stop. Okay, so there's a break statement and there's what we call continue. So let's see. Let me use a number. Let me use a number. The So that it will look as if I'm having a line number. I. Let me print I. So you can see when it gets to 10, 3, 4, 5, 6, 7, 8, 9, 10. When it gets to 10, it what? It breaks. It stops the sequence. Okay? It stops the flow. That's break for you. But the counterpart is continue. There's a keyword called continue. Okay? So if it gets to 10, okay, it skips the next one and jump to 12. Okay? It skips. So continue is more like skip the next one. Let's see. Let's see. 8, 9, 10. I need to be very sure. If F and I'm right. Not too sure. So, but I want you to verify. You can go online now to verify. Continue is to, let's see. Continue C programming. What does it do? I think it's key. The continue is a keyword used within a loop to skip the remaining code. Okay, it skips the remaining code. It skips the remaining code in the current. I immediately jump to the next iteration. Okay, so we have things like that. So syntax. Oh, keep the rest of the when I is 5. If so, it should skip. I wonder why mine is not skipping. So sometimes if I explain,
So I think it's because of the order of the code.
maybe I did not have it or what? Okay,
No, I'm saying that
let me do
maybe if
the
you put continue before print, or no, if you put print at the
yeah.
last line.
Okay, something like this. Let's see. It doesn't work. Let's see. Okay, good, good. can see it skips the 10. Thank you. I love this setup. Okay, so it skips 10. Skips 10 and it continues. All right, that's awesome. Yeah, so that's it. Okay, so um we have things like that. All right, so let's stop here for we've looked really at iteration a lot, um also decision making, right? So I can then we can now move to a topic called pointers, address, and indirection operator. Pointers, address, and indirection operator. So if you can see, a pointer is a variable that holds the memory address. It holds or stores a memory address. Okay? It holds or stores memory address. Sometimes it always memory address of another variable. Okay? So pointers is a variable itself, but what it does is it does not store normal value, it stores an address. Okay? And they are very efficient to use when working with a large data structure or classes. They are very efficient. Okay? They make it possible to avoid duplicating large data items. Okay? So one of the ways I do tell my students, sometimes you can have a large data item, and rather than passing that data along, maybe in memory or in your network, okay, what you do is you pass the address of that data and it is being modified. If let's say there's a trending video, let's say there's a trending video, and the video is let's say 50 MB or 500 MB, and I want the entire class to watch it. The video is 500 MB. Okay, so what's the best way for me? This is a large data, or I can say 50. What's the best way for me to share it with my colleague? Should I take the video and begin to pass it around for everyone? Remember that yes, data is expensive. Or should I just send the address of that video and you watch it? Which one is more um, data friendly? Save um, data consumption. What what do you do? See, you can send a link. Now, when you send the link, what are you actually sending? What are you sending? What are you sending when you are sending a link? I'm waiting for your comments.
Uh, I think you're sending the address of the link on the internet, something like that.
That's awesome. Yes, I love these guys. You are sending the address of where the video is. Okay? Like this, if I need money from you and you could get me, if the money is not much, you can bring it, let's say 5K. But you can tell me, oh, if the money is like 5 million or 50 million or 100 million, will you be carrying the money all around? What you just do is you just get the address, my address, right?
We check.
Huh? Or a check, yeah. So you you carry the money around because it's risky, time consuming, stressful. What you just do is you just get the address, okay? Or you get a check and deposit it into an address. So address is very important. Okay. Thank you, Doc. Address is very important. Okay. So using pointers helps you save you duplicating data. I have that video. I pass it to you. You pass it to your friend. We share it. If it is on the network, it consumes the network bandwidth. Okay. So what you do is you just get the address and send the address. So also in computing, we have a variable that stores the address of another variable. Okay, and that variable is called a pointer. All right. So it helps you to avoid duplicating large data items within a program. So when we will talk about array after this topic, arrays are inherently passed to functions through the use of pointers. Okay, so let's go. Let's talk about data variables and memory. When data variables are declared in a program, physical memory in the RAM is reserved for the variable. So when you create a variable in X, Y, Z, those variables X, Y, Z, their memory being reserved in the RAM. Okay, their space is being reserved in the RAM for those variables. Okay, so the number of bytes that are actually reserved or used for you depends on the data type of the variable. So depending on the data type of the variable, that will determine how large what the memory, the number of bytes that will be reserved for you. Okay. And as programmers, you need to be very memory conservative. You don't you don't declare a large um, storage area for just something small. I just want to say store 10, the but 10, and I am using int. Although it's good to use int at this elementary level, there's also a modifier called short int. So you can see there's also a modifier called short. You can see short int. Yeah. Okay. So that modifier is an integer. X is an integer, but it's a shorter version. So it's just like this. If this is 4 bytes, integers are 4 bytes, 4 bytes. So the short version of it will be 2 bytes. Okay, byte. Now with 2 bytes, a byte is 8 bits. 2 bytes is 16. 2 raised to power 16 will give you the maximum number of size um, it can the largest value you can save in that location. Okay, so let me quickly go and explain. So every variable the space being reserved for the variable you declared is determined by the data type. Okay, so that data type will determine how large or how small the reserved memory should be. Okay, so basically, in the data type defined by ANSI ISO C standard, this is a standard uh, data type definition. It means if you have a character char, char takes care of negative to positive, number. Remember char. In char you have seven, 8 bits. Okay, the number of bytes is 1. Byte means 8 bits. Okay, I hope you guys know that. 0, 1, these are bits. Bit, bit. Okay, if you have 4 of these, any 4 combination of these, we call it a nibble. Ni, double BL, double B, LE. That's nibble. That's any 4 combination. It could be 1, 1, 1, 1. Any 4 combination. Now, if you have 8 combinations of zeros and 1, we call it a byte. Okay? So if you have 1,000 of that, you have a kilobyte. Okay? Megabyte, that's 10 raised to the power 6, and on like that. Gigabytes. So a byte means what? 8 bits. Okay? So this is 8 bits. Then if you do 2 raised to the power 8, 2 raised to the power 8 is 256. Okay, 256. So typical char range from -128 to 0 and to 127. 0 to 1 with 127 is 128. 128 plus 128 is 256. Or you can say unsigned char. Unsigned, when something is unsigned, it means it is what? Positive. Okay? It's just like this. If you have a variable, okay, in variable x, you can see x is naturally positive in mathematics. X is positive, so we don't do plus x. Okay, we don't do plus x. So we just do this. Okay, x is unsigned. It doesn't have a sign. It doesn't have a sign. Okay, it's unsigned. So everything is positive. But once it start having sign, okay, we need to split up the entire byte to take care of the negative and the positive. Okay, so you will always see anytime something is signed, it is splitted up. Anything signed is splitted up. But anything unsigned, it takes only positive. Okay, unsigned takes only positive, no negative. All right, so what I want you to know is char is 1 byte, integer is 2 to 4 bytes, and 4 bytes is 4 times 8, that's 32. 2 raised to the power 32 is 64,000 something. Okay, it's 64,000 something. All right. So short int, remember, int is 4, short will be 2. And that is 16. 2 raised to the power 16. This 2 raised to the power 16 is 2 raised to the power 10 times 2 raised to the power 6. Okay, 2 raised to the power 3 is 8, 2 raised to the power 4 is what? 16. 2 raised to the power 5 is 32. 2 raised to the power 6 is 4. So 64, 2 raised to the power 10 is 10, 4. 64 times 10, 24. We give you around 5,000, blah, blah. Okay, give you this value. So short of this, short of it would. So if you add this to this, you'll get. Okay. So float for float is 4 bytes. 4 bytes. Double is 8 bytes. You will see the number of precision. That is to say, the number of decimal points you can add to it. 6 decimal points, 10 decimal points. And you can have a modifier, say you want a long double to save a very large result, then that would be 10. Okay, so these are just basic uh data types. Uh, so there's a keyword called size of, which you can use to see the size being reserved for each. It is um size of size of x, size of x 2. That's 2 bytes. Okay, that's 2 bytes. Size of x now should be 4. You can see 4 bytes. So it will tell you the size, it will tell you the number of bytes. Okay, when it was short int, it was 2. When it was int, it was 4. Okay, so size of will tell you what the number of bytes being reserved for either a data type or a variable. So you can do size of int. Let's see. Size of int is 4. So you can find size of a variable or size of. The essence is this. If you want to bake a cake, this and you put your dough inside this cake, you will agree with me that your cake would fill up. So the size of your cake is also the size of your what? Of your container. So if you bring your container and say, what's my size? It's also the size of, so I can come here and say size of X or say size of the data type. Okay. So, okay. So, sorry. So you can do size of variable or size of data type, anyone. Okay. So if you look at it, you say type, we are still talking about memory. I want to give you a good understanding. If you declare float x, y, you agree with me that 4 bytes will be reserved for it. If you and also for integer, they are 4 bytes, but for double they are 8 bytes. So if you look at it, float 4, 4, 4, 4. Okay, so for double it has 8 and 8. Okay, so on your stack means first in, last out. So the first variable declared will be passed on to your stack, so it goes to the bottom of your stack, while the topmost, which is R, will be the most current. So this goes to the bottom, followed by Y, followed by I, followed by J, followed by Q, and what will be on the top is R. Okay. So computer memory is addressed by using hexadecimal notation. In 32 bits, the address are 4 bytes. The memory location might have the extra decimal address of this. So when you want to look at memory location are always in that format. So just like this, if I say, give me the address of X, the address of X, so that's the address of X, okay? So the address do change with time. It's not guaranteed that you always have the same value all the time. Uh, Okay. Don't know why it should be changing. So it's not guaranteed that you always have the address of X every time you run it. The compiler can reallocate a new location for you. Okay, so sometimes you have your memory in hexadecimal address like this. Come in, check. Okay, so this is it. So you see hexadecimal 0060FEFC. Okay, because it stores address. Okay, so well, so you can see something like this hexadecimal. Um, so the six variables in the declaration are shown with memory address below. So what they're saying is, if you declare variables like this, you will see them with hexadecimal addresses, more like changing with 44 bytes. Okay, so 8 plus 4, you have C plus 4, O, FO plus 4, you have this. While these ones, they will be changing with 8. D8, D9, DA, BC, D. The next will just be, will be 8 bytes. Okay, so if you want to know the address of any variable, you use the operator and. Okay, that is, we should give you the address of any variable. So any variable you declared in C or C++, always have a data type. That variable will have a variable name. It can have a value and also an address. The address is the location in memory where that variable is. What's that location in memory? You want to know the location in memory that variable is. So to get it, you use the address operator, which is your ampersand. Okay, real new. So this is a variable in memory. If I want to print out the address, I just do this. So it's a pointer or like the address. Okay, it's treated like as an address. So so the hexadecimal address. Oof. So pointers do not have their own keywords such as int, float, double, but pointers have specific way of being declared. Okay, so a pointer variable is declared by specifying the data type to which it will be pointing. The asterisk operator is used in the declaration. So if you want to declare a pointer, remember, if I want to declare a pointer, all I would do is I would just say if it's an integer pointer, that pointer will be pointing to an integer variable. So I would, it's just like your normal um, way of declaring a variable. So let's say this is the pointer's name. You know, this the data type followed by the variable name. Okay, but for pointers, you put an asterisk there. With this, you declare the pointer. Okay, but this pointer does not have, is not pointing at anything. Okay, this is how you, so this is an integer pointer to an integer variable. It could be a floating point pointer, float. So if this is a floating point, it should point to a floating variable. Okay, or it could be a double or a char. So let's just leave it as integer. So I've declared a pointer, but this pointer has no value. Remember that the value of a pointer is the address of another variable. So if I do this, the value, I want to place the value. Now, it should be the address of another variable. So let's say my pointer is pointing at X. How do I make it point to X? I'll say it should hold the address of X. With this pointer is pointing at what? It's pointing at X. So with this, I declare the pointer, but now I initialize it to point to X. The data type must match. If I declare this as float and I try to do something like this, if I run it, I'll be having an issue. Okay. I'll be having an issue. Uh, Look at it. Look at the warning down. Warning, initialization from incompatible pointer type. It's incompatible. Okay. So always want to avoid any flags. So with the pointer now, I can change the content of a variable. If I'm pointing at you, what does that mean? Wait, I can fetch a value from you. I can assign a value to you. So just imagine I do this. Now, if I'm pointing at this variable, what we call it is you are referencing that variable. You are referencing X. You're pointing at X. Let me give you an example. Imagine you took your kid brother or sister to a shopping mart. And most of the time when you take them to shopping mart, what they do is they love to point at something. Auntie, oh uncle, please give me this. I want to buy this. I want this. They point at something. And after a while, they point at another thing. When they point at, let's say, a particular product, what you do as an uncle is you fetch it, you pick it. And if you don't like it, you return it. So what that means is with the pointer, you can access this variable. You can put a value to this variable X. You can also assign a value. So how do you do that? If you are trying to dereference or put a value there, you say X on the asterisk operator. Then with this, you can do this. What this means is put 23. Remember, a pointer does not hold an address or does not hold a normal value. It holds an address. You're saying put 23 to where I am pointing at. So let's say this is my pointer xp x pointer xptr, and I have x here. Let's assume the address of x is 20. Where is saved is 20 in the memory. So the pointer always holds this address 20. So it means it's pointing at this variable. Okay. So when you do this, you are pointing at the variable. Now, if you want to put a value to where you are pointing, you want to put a value to where you're pointing, you use this indirection operator, this asterisk, to say put 23 not to my content, not to my memory location, but to where I'm pointing at. So it means put 23 to this address I'm holding. This address, go to that address and put 23 there. Okay. So look at it. If you look at it, originally, what did I put in X? Originally, what's the value of X? 2. Okay, let's see what X become. And X is now 23. How come? I use the pointer to place 23 to where the pointer is pointing at. Where is the pointer pointing at? just like you're pointing at X, right? So that is how to assign. How do you fetch? How do you fetch? You can do this also. Let me do this. You can do this. Can someone explain to me what I just did? Can someone explain what I just did?
You added 23 to the value of x of the of x that is already x, if that makes sense.
So X becomes what?
X will become 25.
Good. Can you see? X becomes 25. That's a pointer in a nutshell. So the asterisk operator is used to what declare it and also used to reference it. So that's it. Your data type, your asterisk, and your variable name. That's how you declare a pointer. So most of the time, or sometimes, we always use a convention, like saying, if I'm pointing to X, I will say X underscore PTR. This means pointer, or X PTR, or you can do this X, you can do this pointer to X, or X underscore pointer, or X PTR, just to tell you that this is not just normal variable, this is a pointer. Okay, so this is a pointer to a float. So you can do this, some convention like this. Okay, so this is a normal variable. This is a pointer. You can say pointer to an integer pointer. All right. So you declared two integer variables, two pointers. But now this pointer is now pointing at what? The address of count. That is to say, it is now referencing count. This 10 pointer is now referencing 10. Okay. So if you have something like this, okay, what you will have is, if you have A and B, okay, double A, um, int A and double B, A has the value of 78, 75. You can see in the location A, you have 75. In a location called double, you have 82. You remember double have at least about 10 precision decimal places, minimum of 10. Okay, this is a double. Now, a pointer, when you declare the pointer, this is a pointer, A pointer, B pointer. But now, with this statement, you said A PTR is as the address of A. So if A is at this particular address, is saved at this particular address, then APTR, the content of A or the value of APTR will be the address of A, where it's pointing at. Okay, so what it means is whenever you're referencing is saying, oh, go to where I'm pointing at, which is A, and put a value there. Okay, So BPTR, the value of BPTR or what you assign to BPTR is what? The address of B. So the address of B, which is 66FDEC, is now. Okay, so that's it. Now, the indirectional operator, which is the asterisk, when used with a pointer variable, tells that that contains an address, is telling the program, go to the address that I am holding. So just like this, if I put an asterisk with this pointer variable, it means go to this address I'm holding. And what is that address? Which is D. Okay. So you can use it to either assign a value where the pointer is pointing or to get a value where the pointer is pointing. So you can read or you can write to that location. So with this, what did you do? You assign 3 to where the pointer is pointing at, to the address being saved. Okay? Or you can get a value from where the Y pointer is pointing at and assign it to M. So it's a bidirectional tool. All right, so something like this. Yeah, let's see. You declare 3 integer variable A, B, C, and you have one pointer A underscore PTR pointing at A, B underscore PTR pointing at B, C underscore PTR pointing at C. So it means the address of A, 66FDF4 is saved in APTR. The address of B, 66FDF0 is saved at what? So that's what is done, and also for C. But now this third line says put 5 to where the pointer is pointing at. So here, that 5, it says, imagine you want to put 5 in this location. It will say no, put it to this address I'm pointing at. So when you follow the address, then 5 is put there. B, you're saying put 7 to where this pointer is pointing at. Where is the pointer pointing at? FF. So it puts 7 there, and you will see you have the value of 7. So you can add 2 pointers together. You're saying where I'm pointing at, which is B and A, add them together where I'm pointing at, the value, and put it to where C is pointing at. So when you add this, which is 12, you're now putting that 12 to where the C is pointer is pointing at. So it goes, it follows it. Whose address is this? That's C. So it puts 12. So you can add, you can subtract, and do some pointer arithmetic. Okay. So what are pointers used for? That's an assignment. Go and learn what pointers are used for. So I will stop here. Next week, we will continue with a wonderful topic called functions. Functions will be able to do a whole lot and create your own function. Okay? Any questions? Any question, anyone?
So, are we going to get a recording or the slide for the class?
I can't hear you properly because I think where you are is noisy. I can't hear you clearly, actually. So you can put your question in the
I said, are we going to get a recording or the slides for the class?
A recording. Yeah, this is recorded. So I'll put it to my YouTube channel. You go and watch it there. Is that okay? Is that fine?
Yes, sir.
Yes, sir. Yes, sir.
And again, I have some recorded videos on this. So just go online to the channel. I have functions. I've created functions. Go there and look at it. So on these notes, we stop and call it a day. See some other time.
Excuse me, sir. Hey.
Yes.
Okay. Sir, the assignment you gave us, how are we going to submit it, and when are we submitting it, sir?
Which assignment is that?
You asked us now to work on what